So we have our 7 rules of exponents right here on this paper that you guys have. And on the first worksheet, the 7.1, it's two-sided, has WSP and WSPM. And the first worksheet's based on the first 3 rules. Let's just go over the rules real quick. Rule 1 is that when you are multiplying 2 terms with the same base, you simply add those exponents. 2 plus 3 is 5, and you keep the base. Rule 2 is that when you have a power to a power, you simply multiply those, right? 2 times 3 is 6. Keep the base. Rule 3, it's the same thing. Actually, rules 3 and 4 are the same thing. You have parentheses with an exponent on the outside. So up here, where you have the parentheses with the exponent on the outside, power to a power, you multiply. It's the same deal here, but you have many things on the inside of the parentheses. It's still a monomial, but you have 2 times x squared times y times z. Well, technically 2 times x squared times y times z to the 5th. And it's all to the 3rd power. So when you have pure multiplication, you could take that outside power and distribute it to each power on the inside. So when you multiply, or when you distribute a power to a power, you multiply those powers. So it's clear that when you take this 3 and you put it on the power of 2, that becomes 2 to the 3rd. Yes, technically it has an invisible 1 right there, and 3 times 1 is 3, so you get 2 to the 3rd, 2 to the 3rd, okay? And then you distribute the 3 to the square, to the x squared. 3 times 2 is 6, you get x to the 6th. And then distribute the 3 to the y, which there is no power right there, which means there's an invisible 1. 3 times 1 is 3, so you get y to the 3rd. And last but not least, 3 times 5 is 15, so z to the 15th. There's your answer, but there's still something you could do. That 2 to the 3rd becomes 8, and that's why the answer is 8, x to the 6th, y to the 3rd, z to the 15th. So that first worksheet just focuses in on those 3 simple rules. Let's check them out. Let's go to 7.1 WSPM. I'm going to explain the even ones on this video. There's other videos that already explain the odd ones. If we look at number 8, it's pretty simple. It's just rule 1. Yes, there's parentheses, but there's no power on the outside, right? There's no 5 out here that you have to distribute, that you have to multiply 7 times 5. There's no power out here. So when there's no power on the outside of the parentheses, technically you don't need the parentheses. It's really just x times x squared times x to the 7th. You could ignore the parentheses. And rule 1 says that when you're multiplying with the same base, x times x times x, all you got to do is add the exponents. So you have to recognize that there's an invisible 1 right there. So you have 1x here, 2x's there that are being multiplied, 7x's here that are being multiplied. How many x's are being multiplied? You simply add them up and you will get 10. So your answer is x to the 10th, right? The actual math is that you're adding 1 plus 2 is 3, 3 plus 7 is 10. Looking at number 10, it's the same exact deal. You're just adding exponents, and you could just do this in your head. Look at the L to the 2nd and the L to the 3rd. Add the 2 and the 3, and you'll get L to the 5th. There's your answer. And then you can move on to your K's. You got K to the 2nd, K to the invisible 1. Add the 2 plus 1, and you'll get K to the 3rd. And there's your answer. Easy peasy, lemon squeezy. Number 12, same deal. There's no power on the outside, so you don't have to distribute anything. You can just ignore the parentheses and start multiplying. You're going to multiply the c to the 1 times the c to the 3rd. Again, same base, add the exponents. That becomes c to the 4th. Look at the d to the 2nd times d to the 2nd. That's d. Add the 2 plus 2, and you'll get 4. I know you're thinking, what? Yep, it's easy, right? Look at number 14. It's all pure multiplication, again, because there's parentheses, but with no power on the outside. You're not going to be distributing anything. No power, not going to distribute anything. So right here, it is pure multiplication. And when you look at this, this really says 5 times a to the 7th times 4 times a to the 2nd. So we know that multiplying a to the 7th times a to the 2nd, all you do is add 7 plus 2 and get 9. That's rule 1. But notice that you have a regular number 5 that's called the coefficient of 5 and the coefficient of 4. Those are just regular numbers. So what is 5 times 4? That's 20. So there's a big coefficient of 20 on your answer. So the answer is 20a to the 9th. 20a to the 9th. So the only difference between 14 and the previous ones is that we now have numbers, regular numbers, out in the front that we have to multiply. And you could start with those regular numbers, like number 16, there's a regular 7 right here, and there's an invisible 1 out here. So you could just say, okay, 7 times 1, that's 7. Easy. Let's move on to the A's. A to the 5th times A to the 2nd, add 5 plus 2, you're going to get 7. So you have 7A to the 7th so far. Then you can move on to B. B to the 2nd times B to the 3rd, add 2 plus 3, you get B to the 5th. And that's all, folks. 18. Regular numbers out in the front, simply multiply them. -2 times -4, that's +8. Then you can move on to the C, and C, there's a 4 right there, an invisible 1 right there. So 4 plus 1 is 5. And last but not least, you have the D. D, there's 1D, there's 1D. There's going to be a total of 2 Ds that are being multiplied. And there is your answer, 8C to the 5th, D to the 2nd. Number 20, we finally get to something that's not rule 1. This is a power to a power. This is rule 2. And I hope we remember that a power to a power, you simply multiply. So 3 times 12, that's 36. So P to the 36. That is your answer. Number 22, we do have parentheses with the power on the outside. Now notice that on the inside, it's not just a Y. Like up here, we just had a single P to the 3rd to the 12th, power to a power, multiply. But it's not just P on 22. There's actually a coefficient right here. There's a number. In other words, on the inside, you really have the -3 times the Y. And you got to think of the powers. There's a power of 1 on the 3 and a power of 1 on the Y. And this power on the outside needs to get distributed to each of those powers. And of course, a power to a power, you multiply. 3 times 1 is 3. So you're going to end up with -3 to the 3rd, and then 3 times 1 is 3, and get Y to the 3rd. Now, here's the tricky part. Because this -3 is inside parentheses, that negative sign belongs to the 3 because of the parentheses. When you distribute it, you technically still have the -3 inside the parenthesis. So you have -3 to the 3rd and the Y to the 3rd, okay, when you distribute that power of 3. Now, this first term, you really have -3 in parentheses to the 3rd power. So what is that really? That's -3 times -3 times -3. And that is a -27, right? If you go -3 times -3, it's +9. And +9 times that other -3, that'll get you the -27 as the coefficient of your answer. Then you simply bring down the Y to the 3rd. So your answer is -27, Y to the 3rd. If you don't like this idea of distributing and keeping this in parentheses, you could do it the old school way. If you're confused, you could be like, all right, this whole thing right here, this whole thing is in parentheses and it's to the 3rd power. I'm going to write this out 3 times. Like you could actually say, I'm going to write it out 3 times. -3y times -3y times -3y. Then you could be like, I want to rearrange it. -3 times -3 times -3, and then y times y times y. And that'll give you the -27 Y to the 3rd as well. It's totally up to you how you want to do it. Many roads to the same place in math. Number 24. This one's easier. There's no negative sign. Or, wait a minute. Let me go back. I just remembered something. We did that exercise of -1 to a certain power, right? So let me just go, side note. -1 to the 2nd power, that's +1, right? And if we go -1 to the 3rd power, what is that? -1, right? Okay, so if you have a negative term on the inside of the parentheses to an even power, it's going to be positive. So if I say -1 to the 18th power, if you write out -1 times -1 times -1 times -1 18 times, you're going to be able to pair them all up. And when you pair up, a negative times a negative becomes a positive. So because it's even, everything will pair up, which means your answer is +1 or a positive. You could just say your answer is positive. But if you have -1 to an odd power, then you're going to be able to pair them all up except one more is going to be left over, the odd one out. So that means that your answer will be a negative. Does that make sense? So going back to this guy right here, if you're confused about that negative sign, you could just be like, well, a negative number or a negative term to an odd power, that's going to be negative. And then you don't have to worry about the negative anymore. And you could distribute 3 to the third. Oh, that's 3 times 3 times 3. It's 27. And y to the third is y to the third. Okay. Does that make sense? Okay. Let me just do another question that's kind of like that one. Let's say you had a negative 2 x to the, give me a number, whatever you want. 4. Okay, 4. Negative 2 x to the fourth power. And let's say to the negative 5. Okay. It's a similar question. Right off the bat, wait, why negative 5? I'm sorry. Positive 5 power. It's a similar question. Right off the bat, is my answer going to be positive or negative? Negative, because you have an odd power, right? Odd power means that if you were to write this out, negative 2x to the fourth times negative 2x to the fourth times, actually, let me just show it so you guys could see it. Negative 2x to the fourth times negative 2x to the fourth times negative 2x to the fourth times negative 2x to the fourth. Dang, I still need one more, running out of space here. Times negative 2x to the fourth. Okay, when you pair up a negative times a negative, it becomes positive. A negative times a negative becomes positive. There's an extra negative one, so your answer is going to be negative. Does that make sense? Okay, so hopefully that makes sense. So let me go back and just do this math. I already know my answer is going to be negative. And let me just distribute, put the 5 on the 2, and you got to think, what is 2 to the 5th? Well, you could do 2 times 2, that's 4, times 2, that's 8, times 2, that's 16, times 2, that's 32. So we got negative 32, and then put the 5 on the 4, power to a power, multiply x to the 20th. Okay, that wasn't even on the worksheet. I just wanted to explain how to think of that question in a different way. 24. Once again, we have parentheses with an exponent on the outside, so we're going to distribute that outside exponent to each and every term. So when you put the 2 on the 2, that becomes 2 squared, which later will become a 4. When you put the 2 on the 3 right there, power to a power, multiply, you get b to the 6th. When you put the 2 on the 4, power to a power, multiply, you get c to the 8th. So your final answer is going to be the 2 to the 2nd, which is really a 4, b to the 6th, c to the 8th. Moving on to the next even question, which would be 26. They want you to find the area of each figure. This is a square, or it could be a rectangle, but the reality is the area is base times height, right? Or you could also say that the area of a square is a side squared. So however you look at it, you could say base times height, which is, here's your base, here's your height. That's CD times CD. Well, you could use rule 1 of exponents and say c to the 1 times c to the 1 is c to the 2nd. And then d to the 1 times d to the 1 is d to the 2nd. So there's your answer, c squared d squared. Or if you wanted to look at this as a side squared, so here's a side. So a side squared is also the area of a square. So you could say CD in parentheses squared, and you simply distribute using rule 3 of exponents. And that would give you c to the 2nd, d to the 2nd. Same answer, just done a little differently. Let's move on to the back side of this worksheet, which would be 7.1 WSP. Here it is, 7.1 WSP. We're going through the even ones on this worksheet. So number 4, again, there's parentheses, but there's no power on the outside. So technically it's all pure multiplication. You don't even need the parentheses, right? It's really 2 times a times b squared times f squared times 4 times a, so on and so on. So you could just multiply however you want. Now let's start with the coefficients. You have the coefficient of 2, that's the number 2, times, but instead of saying 2 times 8, let's say 2 times 4. 2 times 4 is 8. That's going to be the first part of our answer. And we can move on to the a, which is a to the 1 times a to the 3rd. Add 1 plus 3, and you'll get a to the 4th. And then you move on to b's. You have b to the 2nd times b to the 2nd. Add the exponents. 2 plus 2 is 4. And then you have f to the 2nd times f to the 2nd. Add the 2 plus 2, and you get 4. There's your answer, 8, a to the 4th, b to the 4th, f to the 4th. Number 6, Again, no power to distribute. No power to distribute. You're just multiplying. So start with the coefficients. What is 4 times -2? That's -8. Then you can move on to the g to the third times g to the fifth. Add 3 and 5. That'll give you a g to the 8. Finally, we're going to multiply h times, oh, there are no other h's, so just bring down that h. Okay, this h, just bring it down. And there's your answer, -8 g to the 8 h. Number 8, we finally get to one that has parentheses with an exponent on the outside. We need to distribute that outside exponent. Now, to make things a little less confusing, what we could do is say that any negative term to an odd power will be negative, okay? I hope we remember that. Like if you have -1 in parentheses to the fourth power, that's an even one, you'll have -1 times -1 times -1 times -1. But if you have -1 to the fifth power, well, that'd be -1 times -1 times -1 times -1 times -1. Now, what's the difference here? When it's an even power, you're able to pair them up. Negative times a negative is a positive, negative times a negative is a positive, so your whole answers are going to be positive. When you have an odd power, well, negative times a negative is a positive, negative times a negative is a positive, but then you have an extra negative one, so your answers are going to be negative, okay? It's important to understand that. So if you understand that, then you know you have a negative to the third power, it's odd, your answers are going to be negative, so you don't have to worry about it. Just put a negative down in front. And then you simply distribute the 3 to the x and the 3 to the y. That'll be x to the third, y to the third. Now, what about these guys over here? There's no power to distribute, so you're just going to bring down the multiplication of x and the multiplication of z. So you're going to have times x times z. And then you use rule 1 to add the exponents. You have an x to the third right here and an x to the 1 right there. Add 3 plus 1, and you'll get x to the fourth. Don't forget about the negative sign. That still comes down out in the front. What about the y to the third? Bring that down. What about the z? Bring that down. And there's your final answer, negative x to the fourth, y to the third, z. Number 10, again, you do have parentheses with an exponent on the outside. Distribute that outside exponent to the insides. And you could use a calculator. When you say 2 distributed, that's really going to be a 0.2 to the second power. And if you do that on the calculator, 0.2 to the second power, I believe is 0.04. Okay, I probably won't ask you something like this on the quiz or test, but if it is there, just use a calculator to deal with the exponents. Then distribute 2, put it on the power of 2 on the a, and again, a power to a power you multiply, so that will be a. 2 times 2 is 4, so you're going to have a to the fourth, and then take that 2, distribute it onto the 3, and again, a power to a power you multiply, that's going to be b to the sixth you multiply. So there's your answer. Let's move on. Number 12. Same thing. You have parentheses with an exponent on the outside. Distribute that. Put that right there on the 1/4. So what is 1/4 to the second power? You could do it on the calculator, or you could do it by hand. 1/4 times 1/4 is 1/16. So far, first part of our answer is 1/16. And then you could distribute the 2 to the a, and that'll be a squared. Distribute the 2 to the 3 and a power to a power. Multiply d to the sixth. Moving on. 14. A power to a power to a power, you multiply those. So 2 times 2 is 4, 4 times 2 is 8. So 4 to the 8th is the answer. And of course, if you did this on the calculator, I think it would give you 256. So there is your answer for number 14. Let's move on. 16. Oh, this is a circle. So we need to remember the area of a circle from previous classes. The area of a circle is pi r squared, okay? And r is the distance from the center to the edge. In this case, r is the 5x to the third. So when we're working this out, we're going to have pi times r to the second power, and r, we said, was 5x to the third. That's what they're showing us. So we're going to distribute the outside exponent of the parenthesis to the inside. So put the 2 on the 5. That'll be a 5 squared. Put the 2 on the 3 right there. Power to a power, multiply x to the sixth. And let's not forget about the pi that's in front. So let's bring down that pi as well. And this is technically your answer, but you could do a little bit more. the 5 squared. 5 times 5 is 25. So I would put the 25 first, and then maybe the x to the 6th, and then maybe the pi. But then again, you could also have it as 25 pi x to the 6th. Either one of these is good. And that's where we're going to stop this video. I hope the explanation of these even questions helps you understand rules 1 through 3.